Welcome to the HackerRank Workshop, Ace the Technical Interview, presented to you by CougarCS. My name is Adil Iqbal. I'm the Director of Tutoring at CougarCS, and I'm presenting this with Nykolas Farhangi.
How's it going, guys?
Go ahead. Nykolas is the Vice President of CougarCS. We'd also like to thank Mohammed Usman for helping us put this PowerPoint together. Today, what we're going to be talking about is just in general, what is a technical interview? What kind of technical interview? What types of technical interviews are there? Prep for a technical, and we're going to also give you 6 steps that will help you execute on a technical interview with precision. These work in will work in any interview decision. Courses, but the main crux of it is we're going to have a little friendly competition where you'll have X amount of time to complete some technical interview problems that are hand selected for this particular presentation.
Hey, sorry.
And then we'll review the solutions.
Is Adil breaking out for anyone else, or like cutting out for anyone else?
Yeah, a little bit.
Oh, okay, cool.
Oh,
Maybe let's turn off our video cameras. That might help.
Yeah, that might help.
Okay, cool. Sorry, go ahead, Adil.
Okay, so once we do the problems, then we'll go over the solutions to those problems. And so, Nick, you want to kick us off here?
Yeah. So before we hop in, let's talk about what a technical interview. Oh, whoops, I was muted. Before we get started, let's talk about what a technical interview actually is. So for those of you who may have already had one, a technical interview is an interview where you are given algorithmic problems and you're asked to solve them and explain your solution. So the goal of these interviews is to test your ability to think through the problems. The solution isn't as important as the thought process. What they're really looking to audit is your ability to, walk through a problem, explain your line of thought, and then arrive at a solution. So like today, code interviews are usually language agnostic. So what this means is there isn't any particular language that you have to use. You'll be able to program it in the language that you're most comfortable with. And lastly, candidates will usually be able to use online resources. So this can include Google, Stack Overflow, checking references. Of course, you can't just straight copy an answer from you find online, but you're welcome to use reference sheets, anything that you would normally use to aid yourself while programming. So there are 2 types of technical interviews, the unsupervised and supervised. Some of you guys may have gotten an email like this one we have right here on the right. Some jobs will automatically send you a link to take a code exam right when you apply. So it's like an automatic process. And these are unproctored. You're given 3 to 6 questions typically, and usually a timer like 2 hours to solve it. You'll generally get a link through platforms like HackerRank or LeetCode. For these exams, the questions can be answered in any order, so you're welcome to skip ahead if you get stuck, and really take your time, as much time as you'd like on each question. Employers use these exam results as well as the answers that you put in to see, kind of filter out candidates, the good ones from the ones who might not be so qualified for the job. So getting the answer right is important, but also making your code look pretty, legible, and be something innovative is just as important as well. For the supervised technical interview, this one's usually a later stage in the interview process, where the first one, while the unsupervised one is something you might get immediately. This one you might get after a round or 2 of behavioral interviews. For this kind of interview, it's a code exam where it's proctored by 1 or more interviewers. Usually it might just be one interviewer reading off questions, but there are times when they might do like one guy asking you behavioral questions while the other person is walking you through, asking you to answer technical questions. So this one, like the other one, is also usually 3 to 6 questions, and you normally have less than 2 hours to solve it. Like the interview might be an hour and a half long, and the first 30 minutes might be dedicated to just asking general questions and you asking them questions about the job, and then the rest of the time is spent getting through all the questions they have. So in this kind of interview, the interviewer will read off the question one at a time, and then you're asked to solve it after they read it off. So unlike the other one where you can answer in any order you'd like, this one is you're only going to progress to the next question after you've answered the first one you're given. So one thing that's really important here is that you want to make sure you pace yourself and you're not spending too much time on one question, and asking the interviewer for hints. And the most important thing about this kind of interview is while you're answering your questions, you want to make sure that you're speaking through your thought process and really, vocalizing the any thoughts you're having, as well as coming to the answer itself. So we'll get in later as to how you want to strategize this. So moving forward, now let's hop into how to prep. Adil, you want to take it from here?
Sure, sure. The number one thing you can do is to practice, practice, practice. Uh, you have resources like HackerRank and LeetCode where you can go and um, practice these type of coding problems just on your own. Things you want to definitely understand are things like time complexity, big O time complexity, and spatial complexity. Um, and you definitely want to familiarize yourself with common interviews, questions, and tropes. This HackerRank actually is one of the ways you can do that. The questions that we've picked here is to help familiarize you with things that are going to pop up commonly in like internship interviews and entry level job interviews. You also want to have a good grasp of data structures. So try your hand at solving problems that require you to use like a binary tree or a hash table. The boss fight question that we're going to present to you actually has a bunch of has a situation where you might have to use data structures to get to an optimized solution. These four things are super crucial, and you have to put in the work. And that goes for all of us. During the technical interview, the programming language that you want to choose is the one that you're most comfortable with. The only caveat there is if you are pretty good with a programming language that is in the company's technical stack, it might be a good idea to consider using that programming language just because it's really going to make you shine. But it's not necessary. Very recently I had a job interview where the tech stack was Java, and I asked if I could do the whole interview in Python, and they're like, "Yeah, totally." And I got the internship. So it's definitely your choice. So choose something that you're comfortable with. The thing is, you have to make sure you're managing your time as you're answering these questions. I had a friend of mine who had a technical interview with one of the bank companies, and he spent a lot of time on one of the questions, and he got it right. It was a great time complexity, spatial complexity, but it was one of many questions that the interviewer wanted to ask, and he only answered one of the interviewer's questions, so he didn't actually get the position. That's why you want to try and solve these problems fairly quickly, just in case the interviewer has follow-up questions as well. And the most important thing you can do during the technical interview is talking. You have to talk through your thought process, ask questions. It's more of a back and forth. It's not necessarily they're asking you a question and that's it. You have to answer. It's not an exam. It's more of a collaborative effort to help evaluate your abilities. When you're in this technical interview, a lot of times what they'll ask you to do is, hey, pop up Notepad, or if you're on Mac, they might ask you to pop up text edit, and you have no syntax highlighting, you don't have code completion, so you sort of have nothing but your wits about you. So I have a 6-step process that was given to me by a recruiter, believe it or not. I used to go to a place called Free Code Camp, and I met a bunch of recruiters there, and they showed me this 6-step process that I'm going to share with you now. So these are the 6 steps. The very first step is that when the interviewer is asking you the algorithmic question, you want to be hyper focused on what this guy is saying or this person is saying, and in particular, you want to know what your inputs are, and in what format are your inputs coming into, and what the interviewer expects you to output. and what do those inputs represent? What do those outputs represent? And if there are any constraints. So just to give you an example, there was one technical interview I was in where the interviewer said, "Hey, write a function that will return the product of two numbers." So you and you have to write these functions without using the asterisk. So my inputs there are two integers, and my constraints are I can't use the asterisk, and my output is an integer. Um, but when he was saying that, I have to clarify: is this a floating point number? Is this integer? Just keep that in mind. The second step is to do a deep dive into the constraints. If I'm getting two integers, are they negative integers? Are they positive integers? Like, what's the minimums and maximums that I'm dealing with? Are they longs? If the input's a string, can it be blank? So make sure you clarify those constraints. The third step is to write out test cases. Start with the average case, and then move over to edge cases as well. So, for example, if I were gonna return the product two numbers, my first case might be multiply 2 times 3. My second case might be 0 times 3. Fourth case might be 2 times 0. Third case might be like a negative number. If that's within my minimums and maximums. The fourth step is to, before you start writing code, please just take a moment to come up with a plan and vocalize it. So, for the A times B example, I might start thinking to myself, okay, well, how can I do this? What is multiplication? Well, it's just a repetitive addition, really. So maybe I could use a for loop, and vocalize that plan, because if you're headed down the wrong route, the interviewer might give you hints, especially if you've built a little bit of a relationship with him or her. Once you have a plan in place, you're going to feel a lot more comfortable implementing the code, and you'll be a lot less all over the place. When you start implementing the code, if you haven't come up with an optimized solution, that's fine. Try starting with the brute force, and optimization strategies will present themselves to you. And as you're implementing the code, if you get stuck, stop and ask for feedback. Ask questions. Try to get the interviewer to help you out. And the very last step, this is the most important, is to vocalize the code execution. So for my A times B example, I might say that, okay, here A is equal to 2, B is equal to 3. Then I check, is A equal to 0? If it is, I'll return a 0. Vocalize the code execution, with your test case, and see if you run into any bugs. And if you do, don't stress, just fix the bug and then vocalize another execution. The interviewer might have follow-up questions, and you can field those without having to code after that. So this is a six-step process. Try to do mock interviews with your friends and try to implement the strategy. You'll see that it works like 99% of the time.
Awesome. Okay, thank you so much, Adil. And I just wanted to emphasize a couple points. He says on step 4 of this plan is come up with a plan. Don't just hop into the coding. And I really can't stress that enough. A lot of people will, without saying a word, start typing rapidly and then try to jump a bunch of stuff out. What's really good is, come up with a plan and speak through it. Speak through it with the interviewer. Like Adil said, they'll, cut you off if you're going in the wrong direction. A really big aspect that we want to stress here is that the interviewer is your friend during these interviews. They're able to answer most of your questions. So, don't waste too much time, wondering things you're not sure about. Just ask the question, get an answer, move fast. That's the best thing you can do.
Mm-hmm. Mm-hmm. This whole process is like hopefully will take you 10 to 15 minutes.
Right.
But
cool. But yeah, moving forward. So here is a bunch of helpful resources that we put together. These are a bunch of different websites that you can use to, on the top right, top left, we have a bunch of useful websites you can use to practice coding challenges. Here we have a bunch of good YouTube channels. These are all good coding channels where you can kind of get some experience prepping for the technical interview. For those of you who feel like you're not getting enough interview practice, or you want to like brush up on your ability to speak through your problems, these two mock coding interview sites are awesome. You can volunteer as the interviewer and the interviewee, so you can really feel out what it's like in both those roles. And I mean, most importantly, just getting practice vocalizing your thought process. You know, you don't need to practice, you know, how you're gonna look good for the company. It's mainly how can you vocalize your thought process is what's most important. But we'll stop. Let's stop here for a second. Are there any questions over some of the material we just went over?
I have a question.
Sure. What's up?
So, earlier you guys said that they're going to like, if you do apply to an internship, they're going to send you like a HackerRank challenge. My question is that HackerRank challenge something that everyone that applies is going to get, or is it only for people that passed like the stage where they're looking over the resumes? And my second question is, uh, is there like a time limit for the when you get your hack rate challenge, and they're going to give you a time limit, but let's say you uh, submit the hack rate challenge the day before it's due. Does that make your prospects less favorable?
Okay, great.
You,
Those are some really good questions. I'll start with the first question, which was, will they send you these immediately, or do they like filter some resumes first? Typically, for a lot of these, a lot of the ones that I've applied, like generally some of the bigger companies might do this. Not all companies will do this, but right after you apply, maybe the next day, they'll send you an email with this like, you know, the job title and the HackerRank challenge. And this is like a HackerRank. It's like a competition that we'll do today. You know, 3 to 6 questions, and they'll tell you to some duration when it's due. So you'll be able to answer these questions, and these questions are the same questions you'll find like on HackerRank's website itself. Some
yeah.
employers will program in their own questions though, so you can see that.
Yeah, and as far as you submitting it just before it's due, as long as it's before the due date, you'll be fine. The people who send the HackerRank quiz are the recruiters. The people who make the hiring decision, the hiring manager, likely will not see when you submitted the HackerRank quiz. So
Right.
yeah, you're totally okay as long as you submit it before the deadline. You should be okay.
Right, and it won't always be HackerRank, I should say. This is just HackerRank is a really popular one, but you'll get an email something like this. It'll have some expiration dates, so as long as you complete the exam within the specified duration before this expiration date, you'll be fine. So I wouldn't worry about what time you're doing it and stuff like that.
Yeah,
But yeah, thank you for the question, Mohammed.
very
Thank you, guys.
cool.
Cool. Is there any other questions? We're happy to answer any questions related to this prepping for the technical interview before we hop into the challenge. All right, doesn't sound like it. So with that, let the games begin. We have a HackerRank competition we prepared for today. I'm sending the link into important files. Okay, cool. So if you guys open up important files, there's the link to the HackerRank competition. I'm going to open it up on my end so you guys can see. This is what it's going to look like. Just go over here, click sign up, and then we can get rolling. You'll see you'll be presented with a page like this. So for this comp test, we have 4 questions in the challenge. The first 3 questions are the problems that we're going to be going over today. These are easy to medium-ish problems. They're all categorized as easy, but some of them can be a little bit more tricky. And then the last question, Snakes and Ladders, is our boss fight. So we want to warn you, this is actually a bit of a toughie, but it has a cool solution that for those of you who feel really confident, you can go straight to the boss fight or something. It's worth a lot of points.
Yeah, and I'd just like to add, these particular problems were handpicked because they're very similar to the type of questions that you might get in an actual technical interview. Um, the thing is, though, a lot of times you might feel like, hey, let me just do the brute force solution. Try to find a solution that's a little bit more optimal. If you can do it in linear time, that would be ideal. But if you can't, brute force is fine. Just put down what you can figure out for sure.
Absolutely. And okay, so I'll just kind of go over how we're going to structure this. For each one of these problems, we're going to start by reading off an overview, give you guys some hints, explain the constraints, and go over some examples. And then we're going to give you 20 minutes to try and solve it. And then after going through all 3 questions, we'll then discuss the solutions for each of them, and then wrap up the event for some questions. And then for those of you who are really interested in the boss fight, we'll discuss the boss fight solution at the end of the event, because
Hmm.
not everyone is going to be able to knock this one out. But
Yeah,
cool.
especially not in 20 minutes.
Yeah. All right, cool guys. So let's go ahead and get started. Adil, I'll pass it to you.
Okay. So the very first problem is called Ice Cream Parlor. And what you're given is an array of numbers, and then you're given a target number. Um, and what you're supposed to return from this function is an array of the 2 indices that correspond to the numbers you found in the array that you sort of add up to the target number. One caveat here is you have to assume the array it has one based indexing. So instead of like the indexes being 0, 1, 2, 3, 4, they might be one. They will be 1, 2, 3, 4, 5. The constraints that you have is that the target number will be between 1 and 10,001. So it could be 2 all the way up till 10,000, and the size of the array will be between 2 items and 10,000 items. And here are some examples. So if you have an array 1, 2, 2, 8, and the target number is 4, what you're supposed to return is an array of 2 numbers that are 2 and 3. So the 2 2s that add up to 4 are the index 1 and 2, but because it's 1 based indexing, you have to make sure to increment the indexes to 2 and 3. Nick, if you just want to click real quick. Yeah, yes. And the second example is sort of the same. Your target number is 3, and the 2 numbers that add up to 3 are 1 and 2. And the 1 and the 2 are sitting at the indexes 0 and 4, but you want to return 1 and 5 because the question is asking for 0-based indexing. So for those of you who have a good concept of the problem, I guess now would be a great time to practice and try your best at coming up with the most optimal solution.
All right, cool. So I'm gonna go ahead and set it. Oops.
And
Whoops,
by
that
the
was me
way,
again. Oh, sorry.
Yeah.
I said, cool, thank you for the overview. We're going to go ahead and set a 20-minute timer. If those of you go ahead and take your best shot at this, if you have any questions, feel free to unmute yourselves or drop a question in the event chat. We're happy to help you. If you guys have any questions about the constraints or maybe want a hint, feel free to ask. So problem 2, missing numbers. So in this problem, you're provided 2 arrays of integers, which is ARR and BRR. You're tasked to find which elements of the second array are missing in the first array. So you have some constraints. The array length is going to be between 1 and 10,000, so no worries if it's like bigger than that number. The length of the first array, ARR, is going to be less than or equal to the length of the second array, so BRR. So you can always count on BRR being bigger than or equal to ARR. And then lastly, the difference in lengths of the 2 arrays is going to be less than or equal to 100. So you don't have to worry about them being like significantly smaller than the other, like one array being significantly smaller than the other ones. So I just want to note before we hop into the examples that like you're only going to return each missing number one time, and then you're going to format your return or solution inside of a in ascending order. So what I mean by return each missing number only once is, let's say there's an instance of like 2 3s in the first array, but there's like 4 3s in the second array. You're not going to return 3 2 times. You're only going to say, there's a difference with the number 3. So we're going to return 3 one time. So with that explanation out of the way, let's take a look at some examples. Here we have the first array, which is 7 2 5 3 5. 3 5 3, yeah, 3 5 3, and then the second array 7 2 5 4 6 3 5 3. So what do you guys think the answer to this problem would be, if you guys want to drop it in the chat, or if anyone wants to unmute themselves?
No, I cannot.
No takers?
We got some
Should
people
be
typing.
4 and 6, right?
Yeah, 4 and 6. That's correct. So 4 and 6 would be the missing numbers in this case. So let's take a look at another problem. In the second example, we have 1, 2, 2, 3, 3, 3. And then in the second array, we have 1, 1, 2, 2, 3, 3. So what would be the missing numbers in this case? What would be the solution array? What would it look like?
1 and 3.
All right, perfect. Yeah, that's correct. All right, cool. So yeah, these are a couple of examples. I'm going to go ahead and set a timer for 20 minutes. So if you guys want to go ahead and take a crack at solving this, let us know if you have any questions or, things about the constraints. Feel free to drop any questions in the chat. We're happy to help. So
Mm-hmm.
moving on to the third question. I do want to say, for those of you who, if you're still working on the second question, it might be good to just change gear really quick and try attempting the third question. It's always nice if you ever get like in a jam to just, take your eyes off something and then come back at it later with a refreshed context, with a refreshed view. So, hopping into the third question. This problem is called making anagrams. For this question, you're going to be provided two strings that are going to be named A and B. You're tasked to determine the minimum number of character deletions necessary on both strings so that the remaining strings are anagrams. And just to explain what an anagram is, an anagram is just like basically it's similar to the other question where you want to have each letter appear in the string like the same amount of times. So, if you have a string that's AABB, an anagram to that would be BABA or BBAA, right? What's the same about the strings is they have the same number of characters, the same number of letters, and like the same instance of letters, like the same number of those instances of each letter. So let's go ahead and take a look at the constraints. The string length is going to be between 1 and 10,000, so no worries about checking for something crazier than that. And the strings are only going to consist of lowercase English letters, so all the letters A through Z, all of which are lowercase. So you don't need to worry about anything, uppercase or anything like that. Okay, cool. With those constraints discussed, let's take a look at an example. Here our first string is CDE, and our second string is ABC. So can anyone tell me what's the minimum number of characters that we would need to delete from both of these strings so that those two strings are anagrams to each other? If anyone can unmute themselves or just drop a suggestion in the chat. No worries if you're wrong. I totally just want to encourage some conversation.
Yeah. So we're not judging, guys. Just guess.
Yeah, take a shot.
Muhammad Farah says 3. Phil says remove DE and AB.
Alex says delete the whole string. While
Yeah.
that would be the solution, Alec, it says it needs the minimum number of character deletions. So you gotta find like the least number you can remove as possible.
I think Phil is closest to the right answer, but we need an integer. We need an integer, Phil.
4.
There you go.
Perfect. So yeah, Phil is correct that the answer is delete DE and AB for a total number of 4 character deletions. So you can see, delete D and E from A, so that's 2, and then delete A and B from the second string, and then you have 4. Alright, so awesome. Let's take a look at the second example. We have our first string, which is man, and our second string, which is woman. What is the minimum number of character deletions we need in order to have those strings be anagrams of each other? Yeah, that's right, the one. So they wouldn't be together. It's like, what's the number of strings you need to delete from both minimum number of characters you need to delete from both strings?
Mm-hmm.
Cool,
Phil says 2.
Yeah, Phil says 2 for the second example. That's correct. So we're not going to delete anything from A, and we're going to delete W and O from B.
Okay. So Nick, do you want to talk about the solutions for missing numbers?
Yes. So let's go ahead and I'm going to just give you a quick recap. So for missing numbers, you're given 2 arrays of integers, and you're tasked to determine which elements of the second array are missing in the first array. So just a general approach, broad strokes on how you can go about solving this is you could count the number of instances of each element inside of both arrays, and then do a comparison of each one of those counts, and then anytime there's a difference, you're going to add that number into the solution array instead of ascending order.
Mm-hmm.
So in general, that's how you might want to do it. Use 2 counters. If you can go back, Adil, to that slide. Now I'm going to discuss our approach, how specifically we did it. So for each input array, we're going to initialize an array of length 10,000, and then we're going to fill that up with zeros, and these 2 arrays are going to track the instances of each element inside of the array. For those of you who might be wondering why 10,000, 10,000 is defined in the constraints as the maximum number that any of the numbers in the array is going to be. So the number in the array is going to be between either 1 or 10,000.
Mm-hmm.
So for the second step, we're going to iterate through every single index of each input array, and then for every single index of the first array, if that number is contained, we're going to go ahead and increment inside of our counter array. We're going to increment it +1 for every number inside of the first array. For every element in the second array, we're going to decrement its counter by 1. So for the first array, for every single number that's there, we're going to do a +1. For every single number that's in the second array, we're going to do a -1. In our third step, we're going to iterate from 0 to 10,000, and we're going to take the sum of the absolute we're going to take the sum for every single value. Oh wait, sorry, this is a little confusing how it's worded at the bottom. But basically, anytime where there's a difference between the 2 arrays, where it's not like the sum of those 2 numbers aren't 0, then we're going to insert it into the solution array. So this pseudocode might be a little tricky to explain. Here's the code in C++, and I think this will kind of denote it a little bit easier to understand. But basically what I'm doing is I have an array of counters for A and an array of counters for B's. That syntax up there is basically saying, basically I'm initializing 10,000 values in this array, and they're all going to be 0. Like I'm setting them all to 0 by default. And then I'm saying for every single value inside of BRR, I'm indexing through every single index of the BRR. I'm checking if that index exists inside of ARR because I only want to have one for loop. You know, I could do a for loop for ARR and BRR, but I think it's just cleaner to have a single for loop. And like while we're inside of the size of ARR, I'm going to decrement the ARR counter by 1. Like if that element for that element's position. So let's say the ARR contains like the number 205. It's going to decrement the index 205 in that ARR counter. And then for BRR, I'm gonna do a +1. Like if it's there, I'm gonna increment it by 1. For my solutions array, I'm going to iterate through every single position between 0 and 10,000, and I'm going to take the sum of the A counter plus the B counter. So since the B's are negative and the A's are positive, if there's a difference that isn't 0, like if the sum of those 2 numbers is greater than 0, I know that the solution is going to, I know that there's a difference in those 2 numbers. So basically all I'm doing is I'm checking that the sum of these 2 numbers are not 0. So if it's greater than 0, we know that there's some difference there because the BRR is going to be bigger than the ARR. Now, this is a pretty fast solution. This actually, though you might think like you might feel like an array of 10,000 is pretty huge. It's actually pretty quick for the C++ to compute this. There are some really obvious optimizations you can make here, and some maybe not so obvious solutions, optimizations you can make, and I'll let you guys figure them out for yourselves. In fact, I actually challenge you guys to try and rewrite this in a more efficient way. But yeah, this is a pretty slick solution for that problem.
Mm-hmm.
And I'll take a pause. Are there any questions involving this? No, if there's no questions, I guess we can move on to the third problem. So for the third problem, making anagrams. Let me go full screen here. So we are given 2 strings, and we're tasked to determine what's the minimum number of character deletions we would need in order to make the 2 strings anagrams. So the general solution is for both strings, you want to separately track the number of characters. You want to separately track each character and the number of times that they appear inside of that string. Afterwards, we're going to take the sum of all differences between these 2 trackers, and then that's going to be the minimum number of character differences. So if we have one string that has 3 A's and a second string that has 2 A's, we know the difference between those 2 is 1, so that there's going to be a minimum of 1 character deletion necessary. So here's our approach. This approach takes advantage of the fact that we can use the ASCII value for each character. we know that it's going to be all lowercase characters. So we know like it's going to start with A, which is 97, has a at lowercase a, which has an ASCII value of 97, and then B has an ASCII value of 98, and in increments like that. And we know it's going to be between A and Z lowercase. So basically, we're going to initialize an integer array of length 26, and each index of that array is going to represent each index of that array is going to represent an ASCII character. So the first index is 0, and that's going to be the ASCII variable A minus A. So that would be 0. If the letter is B, it's going to be 98 minus 97, which is 1. C, 99 minus 97 is 2, and then it goes on like that. Our next step is for each character inside of the first string, I'm going to increment that character's count in the count array. And then for each character in the second array, I'm going to decrement that character's count in the count array. For my third step, I'm going to iterate through every single variable of the count array, and I'm going to take the absolute value of each count. So this is either going to be positive or negative. I'm really just interested in like what is the difference between the two characters in the string. So we take the absolute value, we take the sum of every single value inside of that, and then that's our solution there. So let's take a look at this in code. That might have been a lot of words, but you can see the code is actually pretty straightforward. We have a character array. We have a vector of integers which count the frequency of each character. And you can see that I initialize it with length 26, and I fill it up with a bunch of zeros. I say for every single character inside of A, basically the frequency at that character minus the ASCII value A. So it's going to be, if the character is B, it's going to be B minus A, which is 1. We're going to increment that length. We're going to increment that frequency. And then for the value C, I'm going to decrement it. For every single character C inside of B, I'm going to decrement that position inside of the frequency array. At the end, it's going to be all those differences. I'm going to take the sum of the absolute value of all those differences, and then that's going to be my solution. So you can see this is a pretty clever way because I only have a single array instead of having like a separate tracker for both of them, and I moved through it pretty quickly. Does anyone want to take a guess at what the time complexity of this solution is? Feel free to drop it in the chat or maybe unmute yourself.
Yeah, no stress if you get it wrong. Like nobody's judging, Like we're.
Yeah. In fact, I read it's better if you get it wrong because then you memorize it better once you're told the solution.
Yeah.
You have like more of an emotional association with it. All right, so no worries. The time complexity of this is going to be O of n, and that's because we have two for loops. Each one of these for loops is O of n, or, O of the length of the character, or the length of the string. So it's going to be, O of the length of A, then O of the length of B, and then O of 26 afterwards. We can just pretty much call this O of n because you remove all the constants and like scalars. You only want to keep the variable length. And since there's no embedded for loops, this just has a time complexity of O of n, so linear time complexity.
Very cool.
Oh, and yeah, Mohammed says O of n in the chat. Yeah, that's absolutely right. All right, cool. So yeah, today, if you want to go to the next slide, that wraps it up for the solutions. If you guys want to stay after the event, we'll be discussing the solution to the boss fight. For those of you interested in how we answered that. In the important files channel, I dropped the link to the solution document, and that contains the answers in C++ and Python for all of the problems. So you guys can go over that and check that out. If there's any questions, we're here to answer them. And before you guys leave, we have a sign out form, and we'd really appreciate it if you guys would answer the sign out sheet before you hop out.
Yeah, it gives us a lot of really good feedback about how we did and what we can do to improve. So it would be much appreciated.
Yeah, these are like the best things. If you guys appreciate the event, that would be the best thing you can do for us. Let me drop it in the important files. Yeah, that sheet I sent is the sign out sheet.
No, I just have a quick comment. I think like the way that you checked for the anagrams and the missing numbers, how you like have one array that's incrementing and one array that's like decrementing, right? I think that's like a really neat solution. I like never thought you could use tables or arrays like that, And then like you have to check if it's greater than 0. Like that was pretty cool.
Hey, I appreciate it, man. Yeah, like
Yeah.
sometimes you don't necessarily need to like.
Because I just used the nested for loop, honestly. Like it just came in my head like I have to use an ON squared algorithm. I thought you couldn't make it less, but I mean, the more you know, right?
Right, yeah, and I mean, I think that's what's awesome about coming out to events like these is you can see like neat tricks because it's not like the most obvious solution, but it's like a little trick you can do to save some time. Another tool some of you guys might be tempted to use is a map, and I really want to encourage like maps are awesome. Maps are really cool. For those of you who don't know what they are, it's basically just a key value pair. Like to answer this make anagram problem, you could, for instance, have a map of all the characters. So you could say like, if A is there, you put A, and then it's mapped to its count. So like every character has its own it has its own place in the map, and then each character is tied to its count. And you could do the same thing for the other problem where like the keys are going to be the integer number instead of the character.
Very cool. Well, if you have any more questions for us, like we'd love to field them. Any comments? Like we're all about feedback. So,
Can you guys share your the presentation?
Oh
Yeah.
yes. Let me I was actually about to do that. Thank you for reminding me. Let me download this. Yeah, and I'm gonna share the presentation in the chat, same location as the solutions document. Cool. Oh, and before you guys leave, please make sure you fill out that feedback form. It helps us a lot.
Please do. Nick, would that be in the important files?
Yes, the sign out the feedback form is in important files. I'm gonna send it again in event chat. But I thought Q3 was asking for what the anagram would be. That's another thing. That's why it's always good to like during the interview to like ask any questions or clarify the problem if you're ever wondering about that, because they could trick you up like that.
Yeah, the more you ask, you gotta ask, you gotta talk.
So Alex is asking why his solution for anagram won't work. I'm happy to go over that. Let's wait one moment. If there's no more questions for the event, I think we can move on to the post-event stuff, which is discussing the boss fight solution. But Alex, just hold your question for another moment. But yeah, that's it for today's event, guys. Thank you so much for coming out. For those of you interested to hear the solution for the boss fight and have any other questions you want to ask, we'll be here after the event, so please hang on. But for those of you who had a fun event, had a fun time, you're welcome to leave. Yeah, for sure. Thank you for coming, Phil.
Thank you guys very much. It was awesome that you guys could be here.
Yeah, we really appreciated you guys coming out.
I'm sure that we all appreciate it, or you guys organizing this much more. Thank you, guys.
Thanks so much, Mohammed.
Thank you.
All right, cool. I think we can hop into the solution for crossfight.
Okay.
We're gonna go through this really quick, and then Alec, I'm happy to, if you want to show me, you can like share your screen in a little bit after that, and we can go over your solution for the anagrams.
Mm-hmm. But I'll take the boss fight real quick. I don't know if you guys have seen a game of Snakes and Ladders, but you essentially have a 10 by 10 grid of 100 squares, and then you roll a 6-sided die, and then you go from square to square depending on the dice roll. And if you land on a snake, that snake will take you down the 100 square grid, and the ladders will take you up the 100 square grid. And what this question is asking is, what is the minimum number of dice rolls required to get to square number 100? And this problem is way harder than anything you're going to see in a technical interview. But this is what an answer might look like. So for this particular set of snakes and ladders, the answer is 3, because everybody starts at square 1, and then if you roll a 6, you get to square 7. And then if you roll a 5, you get to square 12. Because there's a ladder on square 12, you jump to square number 98, because that's one of the ladders, 12 to 98. And then finally, for your third dice roll, if you roll a 2, you get to 100. So the minimum number of rolls you need to get to square 100 from square 1 is 3. Before we get to talk about a solution, I just want to talk about some things that might need optimizing if you want to get to like a optimal solution. So first and foremost, this is a breadth first search problem. You literally have to search through every potential dice roll from the beginning square and all the consequences of that dice roll from the beginning square to find all the pathways that get you to 100, and then pick the one that has the least number of rolls. So this is a breadth first search problem. One issue we might have is that the snakes and the ladders are given to us in a two-dimensional array. So having to search through this 2D array for every dice roll, that seems like a lot of computation. So maybe putting these in a dict where the key is the starting square and the value is the ending square will help us reduce the time for the algorithm. Another thing that's going to help us out is to use a set, because if you think about it, there is a situation you can get into where you're going up a ladder and then down a snake, and then up a ladder and then down a snake. So you're stuck in this weird infinite loop, and you have to be able to detect that and say, oh, wait a minute, this is an infinite loop. I got to stop right now. And you can use a hash set to detect which squares you visited already. So if you visit them again, you know that you're going in a circle. And just so you know, a hash set is exactly the way a set works in discrete math. It doesn't allow duplicates. The way it's implemented is that the key and the value are the same thing. So you literally can't have duplicates in that kind of data structure. And so this is something you might not know, and this is something maybe I might not know because I might get this wrong here. But in Python, it may be that when you pop the very last element, that it's O of n. I have to look into that. So in places like say C++, a doubly linked list will help you pop and append both in the beginning and in the end of the list in constant time. So these are all ways to help optimize a solution for something like this. And so here's the solution, and let's talk through this. Okay, you're given a 2D array of snakes and ladders. The first thing we do is that we put the snakes and the ladders into a dictionary called paths, so that we can plug in the start square and immediately it'll give us the destination. The second thing we do is we initialize a DQ, and for those people that don't know, a DQ in Python is under the hood implemented as a doubly linked list, and we're going to insert 1,0 in there, and what that represents is that we're on square one and we have 0 rolls, so we haven't rolled anything. This is our starting position. This is starting condition. We're also initializing a set. The way you initialize a hash set in Python is just set, just calling the set method, and they'll give you a set. And so while our DQ is not empty, we're going to get the square and the rolls from there. And if the square is 100, first thing we do is we check the win condition. If the square is 100, we know that we've won the game and we can return the rolls. Otherwise, let's just continue processing, and that means first we visited the square, we add that to our set, and then you have to look through all of the possible rolls. So we're doing a for loop from 1 to 6, and for each roll of the dice, we're checking what's the next square. And if that next square happens to be a square that we visited, or it happens to be a square that is above a 100, meaning we overshot, we stop the computation right there and like, hey, either this is a circle or this is an invalid roll. Let's just forget it and move to the next one. Or if this is not a circle and we haven't overshot, then we know that the square that we're going to land on next is valid. So what we're going to do is, in our queue, we're going to add a new possibility, which is, if next is what if the next square has a snake or a ladder on it, we're going to go to the destination square. Or if it doesn't have a snake or a ladder on it, we're just going to go to that square directly. And each time we're incrementing the rolls. And this loop will continue until we land on square 100. And we're going to return the rolls that are associated with that square. If we go through this whole process, and we find nothing, because if you think about it, there's 100 squares. You could potentially roll a 1, 2, 3, 4, 5, or 6 on each square. There's 600 potential, situations there. If we go through all those situations and find there's no way to win, then we just return -1. And this is what the solution looks like in Python. I don't know if anybody's left in the channel, but that's the solution.
I have some questions if you don't mind.
Yeah, sure.
Please ask.
Yeah. So like you mentioned how it's set. Like I know that it prevents the duplicates, right? Kind of like in a mathematical set. Duplicates.
Yeah.
So, what happens when you do visited.add and then square, and then if that square is already like defined?
Okay, so if it's already in there, it's just not going to add it. And in fact, it might be helpful to like jump into like a compiler or something. Hold on, let me see here. Can you guys see my screen?
I'm a little confused. Yeah, I'm just a little confused. Like why or how a set would prevent like a circular.
Sure.
Going in circles, right?
Sure. So I don't know. Can you see my?
Yeah, I can see the command prompt.
Okay.
Yeah.
So if we do a set, and so let's say we add 4 into it, and then we print the set out. Sorry. Print A. You'll see there's a 4 in there, but if we try to add that 4 again, it's not going to go because the way it's implemented.
So it's still going to be in there. It just won't be a duplicate, right?
It will not be a duplicate. Yeah.
Oh, okay.
So, and the reason that happens is because a hash set is the same as a dict, but the key and the value are the exact same thing. So
I still would have used a dictionary. It's just that like I would just set it to true.
Yeah. I mean, anything works, man. Like whatever.
Yeah,
like
this is something new.
Fits in your head. Yeah, it's totally new. And
I always just use dictionaries. I never use sets, but this is actually like pretty cool though.
Yeah, and
awesome. I love dictionaries.
I use dictionaries all the time. Yeah.
Yeah, those are really awesome data structure.
They just turn ON to O1. It's like depending on how I use it, it helps so much with complexity.
Okay, I'm gonna add a bunch of 2s into the set, and then if I do this, it'll just see no duplicates. Okay, very cool.
So thank you.
Not a problem. Not a problem. But
I thought honestly like it would just have like a compile error or something. But it makes more sense now, yeah. I
mean, it's one of those discrete. I think it's supposed to be a discrete math set. I guess that's what they're trying to model it after.
Yeah, that makes sense.
But does this solution make sense to you at all? Like it does, right?
Yeah.
I'll be honest
with you. The visited thing, it makes more sense now because you're just setting which squares you have already visited, and if you visited there, you don't want to visit there again. So that's what the whole point of a set is. It's to see, it's a track where you've been, and you want to, if in case you go in circles or in case you go back to where you've been before, you would be signaled of that, right?
Yeah, exactly.
Yeah.
It's best research. You're never going to get something like this on a technical interview. Like this is a lot.
I want to say again, like don't worry, you're never gonna see something like so challenging. Generally something, if they ever do give you something that's really challenging, like it's normally they're not expecting you to actually be able to answer it. They really just want to see what's your thought process. Like how can you vocalize your thought process when you're confronted with something that's so difficult.
So would you say that they do like 3 easy problems and then 1 super mega hard problem to see like how you react, or is it just gonna be normal? Like should you just expect easy problems?
It'll be mostly easy problems. Sometimes they might give you a medium, but it's going to be a large quantity of easy problems. It's not if you rest on your laurels. If you see the first problem and it's like, oh, this is so easy, I'm going to get this job. No, dude, there's going to be more coming up. So you got to be quick about it. You-
Yeah,
I'm
you
just
gotta
asking
manage
your
your time.
experience. Like, have you ever had a situation where the last problem's like a final boss? You know what I mean? Like, have you haven't got these yet? Like,
I'll tell you
in your job
from my
interviews.
experience. I've had maybe like 6 or 7 coding interviews, and I'd say most of the time it's like just easy medium problems. Sometimes they'll give you something that seems challenging, but it's more just like, could you kind of, it won't necessarily be to solve it. They'll show you a solution and say, what's wrong here? Like, can you fix like whatever issue they're telling you.
Oh, I see. I
I'd
see.
say in 2 situations I was given like a handful of easy medium problems, and at the very end they gave me something that was like actually really challenging, and said, like, what can you make of this? And again, like, they don't have the expectation that you solve it, so it's mainly explain your thought process. Another example of something you might find interesting is one time I was shown like a code snippet, like a few functions in this language that is like, it was private to that company. They had their own internal language, and they were like,
What?
yeah, they were like, can you
Oh,
understand? Like, can you explain line by line what's going on here?
oh my
So it's
God.
like, what's important is like, can you translate your familiarity with your programming? Whoa,
Like
matrix.
control structures.
Sorry. I
So
was
like
like,
you should be able to identify control structures and
Yeah.
things like that in their language.
Yeah, like, can you, because conceptually all languages are pretty similar. So
Yeah, yeah.
it's like, can you kind of walk it through? So yeah,
That's
they
pretty
might.
cool.
Yeah,
It's a good.
yeah. So you'll see a few different things.
Interesting. Yeah, I mean, you can never truly like know what to expect when it comes to these, but I did gain a lot of insights thanks to you, to both of y'all, for like what exactly or not like what I should see when I do something like that, or how I should prepare. Because I mean, like, I've been doing other things, like I've been doing caddis competitions, and those are pretty fun.
Mm-hmm.
And what's it called? The other one, lead code.
The code.
But HackerRank, dude, like this, honestly, it's probably like the most challenging out of all of those. Definitely had the most challenging
I
questions or
mean,
problems here.
they're all pretty hard, but
Yeah.
the more you practice you get in, the better you're gonna do, and that's just a fact of the
Yeah, I'll
situation.
definitely prioritize these ones from now on, to be honest, because I think like the HackerRank problems, they're pretty they're not like one step, it's like, at least for me,
Mm-hmm.
it's more intensive than other things that I've tried.
Very
Yeah,
cool.
yeah.